Hey, what is up guys? Welcome back to the channel. This is Dale Co's Tutorials. Today we're going to jump a little further into Java programming. So if you made it this far, you've already seen our videos on installing Netbeans on a virtual machine and configuring Netbeans so that it looks nice for you. Netbeans is our IDE. IDE stands for an Integrated Development Environment, and it's very cool. It's very easy to use when you're writing code, much better than a text editor. But what we are going to do in today's video is get rid of all that. We are going to move away from Netbeans for a little bit, and we're going to jump into creating pseudocode. Now, pseudocode should not be written in your IDE. So until we dive into Java specifically, you should not do anything at all in Netbeans. You shouldn't do it. Instead, we're going to take a step back, and instead we're going to use Notepad, which is probably the best tool on your computer for writing pseudocode. Don't use Microsoft Word, don't use Pages, don't use Notes, simply use Notepad, right? Or whatever the Mac equivalent of that happens to be. But it should be good to go to use Notepad because it takes away all the formatting mumbo jumbo. Now, I know you can adjust Microsoft Word settings to make it easier for you to write pseudocode, but I think it's even easier for you just to open Notepad Plus, or even better, Notepad++, and use that instead. But before we do that, before we write our first line of code together, guys, I want you to sit back and just watch this video for just a second. Just watch this video. We're going to walk through pseudocode together. I'm going to walk you through programming logic, and I'm going to walk you through how we approach creating our first set of actual programs. So I know there's a lot of big words there: programs, Netbeans, IDE. Especially if you're not an experienced programmer, those are probably going to be very scary for you. Don't worry about it. We're going to take baby steps through it right now. I'm going to give you the 10,000 foot overview of pseudocode, and then at the end of this video, I'm going to walk through creating some pseudocode with you. So remember, the point of pseudocode is to be very general. The point of pseudocode is to just give you the 10,000 foot view of a code. So don't get hung up on syntax. If you get confused, it's okay. Just hang with me. You can always watch this video again. But again, what we're doing in this video is not tremendously important to Java, with the exception of it is a tremendously important step in preparation for Java, if that makes sense. So without further introduction, let's dive into the strange concept known as pseudocode. So I'm going to stay in this top corner the entire video. I hope I don't get in the way of any graphics or words, but if I do, I will do my best to clarify those as we go along. Let's talk about pseudocode. What on earth is pseudocode? Pseudocode is a word created from two other words. Those words are pseudo, which, as you can see right here, meaning not genuine, spurious, or sham, right? Pseudo means fake, means not real, not genuine. Pseudocode, right? And of course, a code, as we know, is a system of words, letters, or figures, or other symbols substituted for words that have a purpose, right, especially for secrecy. So if we have a pseudocode, we have a fake code, right? A pseudocode is a fake code. What you see on your screen right now is an example of a fake code, right? I'll put myself right there. Maybe it's a little bit easier for the time being. Is a fake code. It's not a real code. This is not written in any specific language. You could just as easily take this pseudocode and apply it to C++, and apply it to Python, and apply it to whatever language you happen to be writing in. And the result should be pretty similar. Why? Because pseudocode is not intended to be compiled into an actual result. It's intended to act as a blueprint, to act as a guide. So this is fake code, and this is an example of what it might look like. Now, we're going to step through this entire thing together from start to finish here, but just so you know, this is what it looks like. Now, I want you to notice in particular that this is an organized document. It's not just a bunch of words thrown on paper. It's a step above brainstorming and a step below submitting a polished off program. right? So we have what's called a class here. We have it inside our main method, which is right here, right? We have different things happening inside the code, and of course it executes at the very end. Now again, I told you sit back, relax, and enjoy. Don't worry about typing this out. Don't worry about this. Just watch through and just walk with me. I promise. I know you're gonna feel like you want to type stuff down or do stuff with me. Just watch. Just sit back and enjoy. So. We are going to go ahead and move to the next slide here. So why on earth do we use pseudocode if it's not real code? If it's fake code, what on earth is the benefit to using it, right? Pseudocode simply it simplifies the code. Right? Java in particular is known for being very verbose. And verbose is a word that you'll hear a lot all throughout IT, right? Verbose means it's going to give you a lot of words. Java in particular gives you a lot of words. Writing something as simple as simply having the program spit out a name or print out a line takes a whole lot of jargon. Right? When you put it in pseudocode, you take a lot of the jargon out and you get to the meat and potatoes of what it's supposed to actually do. So pseudocode doesn't actually compile, which is okay, but you can see it more clearly in your mind. When I see a pseudocode, I know right away what it's going to do, how it's organized, even before I've really taken a specific look into the very, very, very minuscule details of that particular pseudocode document. So even though it doesn't compile and you can't run a pseudocode, it is very useful for keeping things organized in your mind. Remember that you're going to think about things very differently than your computer thinks about things, because you are a person and your computer is a computer. Right? So you're going to see your pseudocode and you're going to know right away what you want to accomplish. The computer, on the other hand, is not going to see that. So it's kind of like the blueprint of a house or the outline of a story. Right? So if you were building a house or some building, you probably have some form of structure in mind, some blueprint in mind. That is what pseudocode is. It's this paper-thin copy of what you want to accomplish, but you can see it on paper, simplified down, boiled down, and it's easy and ready to go for you. Pseudocode simply shows what you are trying to accomplish without worrying about complicated jargon, right? Remember that jargon is important. How you write is important, especially when you're talking to a computer that literally has no idea what you're trying to say and only knows what you have said. So pseudocode shows what you're trying to accomplish so that you can compute it and you can make sure that the actual jargon is right when it comes time to actually write your first Java program. So, much like a writer should never just jump into writing a book or an essay, a programmer should never just jump into a program. If you have a goal in mind, that's great, but you should take some time to think about the steps that are going to be involved with creating this process, right? Now, in a business sense, maybe you're working with a company. That company needs you to create a program that will take user identifications, match it up with passwords, grant them access, grant certain permissions, etc. That's a lot of steps involved. If you don't have a list going or an outline involved, then you could get very lost in your own program very easily. So long story short, don't just jump into a program. You should always have some semblance of where you're going much before you start to actually write out your Java program. Let's take a closer look at pseudocode. So anytime you write code, pseudocode, Java, Python, C++, or anything else, you have to visualize it in a particular way, right? You are imagining, you're creating a structure basically for how you want your code to be. You're creating the outline, the skeleton, right? Now, I like to imagine my codes as little castles. That's because I am a dork. I am a huge nerd, right? But castles also have this very clearly defined structure. We have a wall along the outside, maybe a moat or something, but some kind of boundary, right, between the castle, and then we have a system of things in the middle, right? And it always leads up into another thing, right? Castles are layered. They have a very distinct structure. So if you think of your code as a castle, we can build your code in a similar way to building a castle. Let me dive into a little more detail. Just know that you might imagine something a little bit different. I just happen to really like castles. So I think castles are easy and they're fun. So if you think of something different, maybe a house, maybe a city, I don't know. That's fine and dandy. But just understand that a code is like a castle. Okay, so we're going to dive into our next slide here. So what are the walls of our Java castle, right? Walls are the boundaries of our castle. They separate what happens inside the castle from what happens outside the castle. So inside our Java code, we have to create walls. That way we know what is inside our castle and what is outside and what doesn't matter to us anymore, right? Whenever we're at a program, we should always be in control of what happens inside of our program, 100% of the time. So we have to create walls. We have to create a way for data to enter and data to exit our program effectively. Let's talk about how we make these Java walls. So I'm going to call it JavaWalls here. Now, JavaWalls is not an official thing, right? If you go to any Java programmer and you ask them about JavaWalls, they're going to look at you like you're freaking crazy, because that is a word I made up. Me in my house, sitting in front of my computer, I made up this word, as isolated as I could be. So JavaWalls is not a thing. But I'm going to refer to our castle as a class, and we'll give it our first set of boundaries like this. This is our class Castle Java, right? We're naming our class here Castle Java, right? That is the first set of walls here, right? Now that's like our moat. Right, that's going to surround the entire castle. And then we have this thing called the main method right here. Now, you can use multiple classes and multiple methods and things depending on what you're doing with Java. But for our purposes, we're going to assume we're just using one of each. So we have one moat surrounding our entire castle. We have one method, which is our main method right here. Okay, that is the stone wall. So we have a moat and we have a stone wall, and then we have everything happening inside of our stone wall and inside of our moat. I know that looking at this is not as exciting as looking at an actual castle, but I think that once you get the hang of this, you'll have a better hang on what's going on inside a Java program. So so once you see this, you'll know that you are in our new castle. Welcome to our castle. This is Castle Java. Just kidding. Okay, I know that's lame. But just to give you an idea of what it should look and feel like, let's go ahead and take a look at how we're going to set up our next set of boundaries here. So we've started our walls. We have to finish our walls, go all the way around our program. This is kind of like the back end here. We have return, which is the end of our main method, and we have the end class, which is how we end the class. It's how we mark the end of our castle, right? So just like castle walls surround a castle, our class name and our main class statements surround our whole program, right? So we set our upper boundary by saying this is where our castle begins. Now, where does our castle end? It ends here by saying we have return and end class. Now, I know it's difficult to visualize right now. That's why I'm going to go ahead and put them next to one another here. So we have class Castle Java with a main method. We have a return, and then we have an end class. And all of our code should happen inside of here, right? All of our village people should be running around inside here. Our prince is inside here. Our princesses are inside here. Our knights, our round table. Anything that happens inside our castle, inside our code, is going to happen inside of here, inside these walls here, the class Castle Java and the main method. So in real Java, not pseudocode, you're probably going to use many different classes and many different methods. But for introductory reasons, we're going to just assume everything happens here, right? So even though there's another kingdom somewhere over here, and even though there's plains in the middle here and maybe some mountains over here, all we're going to worry about is this, right? What's happening inside our actual castle, our main class, right? So this is what it looks like when we take that 10,000 foot view, okay? We have class, your favorite team, and the end class down here. We have main and we have return, right? Now, I know I haven't spoken specifically about what syntax I'm using here, why this is lowercase, why that should be uppercase. That's a typo on my end, but pretend that's uppercase, right? Class, your favorite team. And why we've put these, why we've rephrased these this way, right? We don't know why we have a main method here, what return even means, and what end class means, right? We don't know what any of these means except to know that what we've done is just create our castle walls. We've created the boundaries of our program. That's it. Right? That's all that this means. And then we have all kinds of things happening in the middle here. Now, the order this happens in the middle matters. I understand that in the real world, many things could be happening at the same time inside an actual castle. Not the case in Java. Java will execute this one line at a time. It will look at this before it looks at this down here. It will look at this before it looks at this down here, and it will always do that. So for our purposes, it's going to do one thing at a time. Let's go ahead and dive into that first section there, which remember was the declarations section right there. Declarations are where we decide what variables we are going to need. You'll see I have just a list of things here, but I'm not doing anything with them. I'm just listing them out, right? String. So what on earth is a string? What is favorite team, city, country, etc.? Declarations is where we decide what variables we are going to use, what variables we are going to need. I'm going to make myself a little bit smaller there for you so you can see this full equation. But don't get scared. This is a very rough equation. I probably couldn't solve this equation if you gave it to me just on a piece of paper. I don't really know what most of these things mean. Maybe if you happen to know these variables. I don't know. But I don't know what this means, so don't get scared. Don't be afraid. Just because you think of variables in terms of this giant equation, variables in pseudocode is a little bit different than variables in Java, and they're very different from actual variables that you'll see here. Even though we still do functions with them, we still add things to them, multiply, divide, etc. You're probably never going to use a program like an equation this complicated whenever you're writing a Java program. And if you are, it's probably going to be simplified down for you so that the computer will take care of all the blunt work for you. So you don't have to do very much with it. But understand that, the functions are the same. Variables do things just like you do in math class, where you can add things to them, multiply, divide. But it's probably not going to be this complicated. So just because you hear the word variable, don't get afraid. Don't be nervous when you hear that when you hear that phraseology. Don't be worried about that. Instead, just know with confidence that a variable is just a variable. It's just a thing that we're messing with inside our program. So let's go ahead and dive into our next one here. So variables. So for our purposes, there are exactly two and only two types of data. That's it. Nothing else exists in the world of Java except these two types of data. They are very important that you don't. It's very important that you don't confuse them between the three forms of data, right? So you can have one of two types and one of three forms, right? But not two types and not two of the three forms, if that makes sense. So there are two types of data, and they are text data and they are numeric data. Okay, text data and numeric data. Don't get those confused. I'm going to dive a little more in detail in the next slides here, but just understand the two types of data: text, meaning words, phrases, names, and numeric data, meaning numbers. The three forms of data are literal, constants, and variables. Let's dive into what each of those means a little more in detail here. So text data is the first type of data that we're going to mess with, right? A text data is often called a string. You see I have a picture of shoestrings here, right? That drives me nuts because I want to tie this shoe more than anything in the whole world. So we'll say that a text data type is often called a string. It's referred to as a string. And it's the same thing across multiple different programming languages. String data definitely appear in Python. They definitely appear in C++. And they definitely appear in Java. So you want to make sure that, that string means text. Text means strings. These two terms are basically interchangeable, except Java doesn't know what text means. Java knows what string means. I didn't name it string. I don't really know the word association that led somebody to one point call a word a string, but for our purposes, understand that text and string mean the same thing. String data consists of letters, symbols, for example, a name or a place. So the name Dale, the name Dave, the name Ryan, right? A place, Paris, place, France, place, San Francisco, right? It could mean Coke. It could mean bottle. It could mean charger for your phone in the car. It could mean anything as long as it's not a number. So text data is just a word. Right. The next thing we have is numeric data. Numeric data is probably what's going to take up the vast majority of the data that you use when you're using Java or any other programming language, because odds are string data, you can't do much with it unless you're parsing it into an int somehow. But for the most part, numeric data is what you're going to be messing with, because that's where computation happens. That's where we calculate. And that's why we have numbers over here, right? Numeric means number, numeric, number, num. Num is, there's a reason I'm saying num and not number, but that's We'll get into that a little bit later. Numeric and numbers are right here just fine. So numeric data is exactly what one might surmise it to be. Data that consists of numbers, right? I can't stress that enough. Numeric data equals numbers. Number data only exists as digits, and they're able to interact with operations known as expressions. That's a very complicated way of saying you can take the number 3, you can add it to number 7, you can multiply it to number 7, you can divide it by number 7, right? Or you can subtract it from number 7, right? You can do all these operators on all these numbers in any combination. So you could do 346 plus 702, etc., etc. It doesn't really matter what you want to do, but understand that you can do operations with numeric data. So the TLDR on that is numeric data equals numbers. Okay, don't overthink it. Numeric equals numbers, text equals string, text equals words. Okay, let's talk about the 3 forms of data. We had 2 types of data. They were numeric and they were text. There are 3 forms of data, right? Literal data. Literal data refers to, well, exactly what you think it is, right? Literally orange, right? This is an orange, and it is literally an orange, right? This is written literally in the color orange, right? Orange refers to exactly what it is. Now, most often, this is strings. Most often, this is in the context of strings. Name equals Dale, for example, right? Means that the variable name literally contains Dale. Right now, you could change Dale to say Dale R, to say Dale X, to say Dale Codes. Then the name variable will mean whatever is written in those quotes exactly, verbatim. Data form 2 is what's called a named constant, right? A named constant is a constant that we have given a name. Quite simply, these values will never change no matter what throughout the entire program. As long as you are in Castle Java, the named constants do not change under any and all circumstances, right? So these values never change. A baker's dozen equals 13, right? Now, you'll see the syntax there I've written this in. I've done that on purpose, right? Baker's underscore dozen in all caps. That is pretty much good practice to get into writing out named constants that way. Now, again, you're probably not writing anything down throughout this video. That's okay. I told you not to worry about syntax too much, but I'm just pointing this out to you know that this is important. This will come back later. This is on the quiz. This is on the test. This is on the exam. Do not forget this. Baker's underscore dozen equals 13. All right, this means that throughout the entire program, inside our kingdom, right? Inside Castle Java, a baker's dozen will always equal 13, no matter what. You cannot ever change the variable baker's dozen to mean anything other than the number 13. You can't do it, no matter what. So that's the point of this right here. The baker's dozen equals 13. And it never changes no matter what. Now, the reason it's important that you write it out this way is so other programmers know when they're looking at your source code that this is a constant. This never changes, and that's totally fine. The more things we can do for future programmers to make our program better later on, the better off we're going to be overall. So a named constant is a constant that never changes. A baker's dozen equals 13 means this is a constant and it will always equal 13. And no matter what, you can never change that value ever. Can't stress that enough. So let's talk about number 3. Data form 3 is a variable, right? A variable, as you might expect, might change throughout a program. So, for example, let's say you have a deck of cards. And right now I say, hey, pick a card, right? Right now I have 52 cards in my hand. When you take one, you light it on fire, you bury the ashes on another planet. Now my deck of cards variable only contains 52. So we started out with one numeric with some numeric data inside that variable, right? Inside that variable, that deck of cards variable, and we've taken one away from it to change the value of that variable, right? We've changed it from 52 to 51, right? So that is what a variable is, right? Cool. Any questions? I don't know. Email a professor. Just kidding. All right, let's talk about our next section here, which is the declaration section, just to show you where that's at in our overall program. We'll go back. And I'll show you right here. We've created our castle walls. The first thing we're going to do is declare our variables, right? We'll do that right over here. There it is. So let's make our declarations. Now, we've created the beginnings of a program here called class castle Java. We've created a main method. So we've created a moat. We've created our walls. And inside our walls, we've made some declarations, right? We've declared a law. In this case, we're only using string values, if I'm not mistaken. Yes. In this case, we only have 5 variables, and they are all string, right? Just like I said before, a string data type happens to be a text data type. So each of these variables happens to be a text data type string. We've given them the names: prince name, fair maiden 1, string fair maiden 2, string fair maiden 3. Now I'm inflecting my voice on purpose because I want you to see that it's camel case. It starts off lowercase there, string under lowercase, prince, it's uppercase, name, fair maiden 1, right? And that's just good practice to get into. To be honest with you, it doesn't make that big of a difference when it comes to compiling, but as far as like making sure your program looks appropriate and is readable, you want to make sure that you are following the camel case syntax there. So each of these variables does happen to be a text data type. As you can tell by this, it says string, meaning it's a text data type. If this said number or num choice, it would be a numeric data type. But each of these variables happens to be, oh, I said that already. We delineate the text data type by using the term string, right? If any of these were numeric, we would simply use the term num instead of string. So, any questions about that? I don't know. Email me, call me, raise your hand. I'll call on you in class. Just kidding. So let's use these variables. Let's get input. This is what the section looks like where we are using variables and getting the input from the user. So let's go back to where we were before. You'll see that we just did this up here. Now we're in this phase right here, right? Which is we are getting information from our user. So in this case, we're having an output line, which means our computer is spitting out to us this question. Greetings, my lord. 'Tis a fine day for a wedding. What is your name again? And this is where our user is going to input their name, right? The name of the prince of our castle, right? Greetings, my lord. 'Tis a fine day for a wedding. What is your name again? They're going to put prince name in. Now, remember, we're expecting this to be a string. We're expecting this to be a word, a text variable, right? That's going to go right here. String, right? Prince name. So input prince name, we're expecting them to say some kind of string, not a number. If they write a number, it's going to crash our program, but that's okay. We'll figure out how to bulletproof a program later on. For now, we're going to assume that our user is going to do exactly what we want them to do. Input prince name means they're going to input the name of a prince. And then we're going to ask him one more question. Who is the first damsel in distress, right? Which happens to be our fair maiden 1. We're expecting them to enter in the name of fair maiden 1, whoever that happens to be. So if prince happens to be Dale, fair maiden 1 might be, I don't know, Tina, Susie, whatever you name that happens to be, right? We're expecting a string to go in there. That would be fine. And then we're going to do that 2 more times to create a grand total of 4 variables so far. Or I'm sorry, to fill up 4 so far. So we have output, greetings, my lord, input prince name, Dale, and then our fair maiden 1, fair maiden 2, fair maiden 3, and then we're going to save one of them, right? That's what this means right here. That's this entire section right here. Remember, when we do this, when we do string prince name, string fair maiden 1, string fair maiden 2, 3, and string choice, we create variables, right? We have created objects. We've created things inside our program, but we've only created empty people, right? We've created a bunch of zombies. They don't have any value to them yet, right? We need to give them names. We need to give them identities, give them things that we know that they are, right? So right now, these people are zombies. They exist. They don't really do anything. Let's give them a purpose. And that's what this is for, right? We created 5 variables. We're going to give them some pizzazz, give them some name, give them some flavor, right? In this case, we're going to output something to the user. We're going to declare to ask him a name for our prince. So give us a name for our prince. And then we're going to do the same thing for fair maiden 1, same thing for fair maiden 2, same thing for fair maiden 3. What do we have going on here? We have output. This is what the output's going to flash to the user. Greetings, my lord. In words, this is what it's going to flash on the screen. Right? Greetings, my lord. 'Tis a fine day for a wedding. What is your name again? Right? That's in quotes. Notice the space right here. That's because our blinking cursor is going to go right there. That's where our user is going to input their name. Input prince name. Same thing here. Output, comma, quote. Who is the first damsel? Who is the second damsel? Who is the third damsel? Those are all going to be the same line just about, except we're changing first, second, and third, right? Input fair maiden 3, fair maiden 2, fair maiden 1. Bingo, that looks great. And then finally, we have our final output here. Final output. Whom shall you save, my lord? And now we are going to save one of these fair dangers. We'll say from the fire-breathing dragon, just because we can. So that's what we're doing here, is we are taking our zombies, we're giving them names, giving them identities, and we're taking this zombie, and we're turning them into one of these beautiful princesses, right? So we have created our variables, we've given them values, now we have to do something with them, right? Now in programming language, we call this processing, right? We've taken information from the user, now we're doing something with it. That is called processing. That means I'm taking what you have, I'm doing something with it, I'm taking what you have, I'm making it mean something, right? In Castle Java, we're going to call this choosing our princess, right? Or taking our princess data and then doing something with it, right? So let's go ahead and process the pseudocode. Now, in this case, I'm using what's called an if statement. Do not worry too much about the decision statements here. We will dive more heavily into those later on when the time matters, when it matters a little bit more. But for our purposes right now, imagine what we've done here. We've created a castle. We've created 5 variables in this castle. 4 of them are people variables. 1 of them is a choice variable, right? The 4 people are our prince. We have 3 fair maidens, and we've given him the choice to choose one. We're saying if you choose door number 1, you have chosen excellent choice, sire. If you choose door number 2, right? If choice equals fair maiden 2, you've chosen fair maiden 2. Excellent choice, sire. But if you choose choice number 3, you've chosen the troll. I just wanted to have a little bit of fun with that, but that's an example of what we might do. We might have our user have one choice and it means something, have another choice and means something different, have choice number 3 and have it be the wrong choice, or have them lose the game for some reason. By the way, you just lost the game because I just lost the game. Just kidding. Anyway. So let's say that if you choose Fair Maiden 1, we'll say this is Fair Maiden 1, Fair Maiden 2, Fair Maiden 3. This is really our troll. Just kidding. This is really our troll. Just kidding. This is really our troll. It doesn't really matter. But understand that one of these is Fair Maiden 3. Fair Maiden 3 is our troll, which is delineated right here. Output, you have chosen Fair Maiden 3. You have chosen the troll. And then end if is where we're going to end the if statements entirely. So this is what processing looks like in terms of pseudocode. Now, I want you to pay attention to where the quotes are, to some of the constants we have going on here, between these commas here, between the equal signs, between the choice variable here, between the variables being declared here, and understand that's pretty common syntax for pseudocode. But again, pseudocode doesn't really exist. So even though this is how it's done in this case and how it looks nice and how it's pretty much done across the board depending upon what programmer you're talking to, this can change depending upon who you're working with. Pseudocode is fake code, so you can't really do it wrong. You can't mess up. Congratulations, no matter what. You can never mess up pseudocode, but you can fail to accomplish the ultimate task. But in this case, our task was to create a program, was to create a castle, was to have our prince guy decide which of these 3 maidens he would like to save, and he did exactly that. He chooses one of these 3. If he chooses this, it's this. If he chooses this one, it's this one. If he chooses this one, it's this one. Fantastic. This is what the whole program looks like from a bird's eye view. We've created class Castle Java at the very top up here, which is very nice. We've created a main method, so we've created a moat surrounding our castle. We've created a method inside our castle, which is the same as creating our castle walls. The first thing we did was make our zombies, right? We made our characters, and then we made our zombies a little bit more than zombies. We gave them names. We gave them identities, right? You could do anything here. You could give them heights. You could give them names. You could give them, genders. You could give them clothing. Whatever you want to do. You can do it all right here, right? And then we're going to process that data right here. We're going to do something with that information right here. And then finally, we're going to return, meaning we are out of our castle. We are zooming out and we are saying, and they lived happily ever after, right? That's the end of our fairy tale here. That is pseudocode in a nutshell. So let's go ahead and take a bird's eye view here at pseudocode now that you've seen what it looks like here when it's all put together, right? About pseudocode. Syntax matters, right? But not really. The better your syntax can be while you're writing pseudocode, the easier it's going to be for you to write your actual Java code, which is what you're going for. Ideally, you should be able to copy-paste your pseudocode directly into your Java program, and it should compile just right, except I don't want you to do that. I want you to simply put your pseudocode down in such a way that that you understand it, that it's clear to someone just reading over it, but it doesn't necessarily compile. It just looks in a way that it's organized. So we can use this as a blueprint, as an outline, as a roadmap later on, right? It is less important for grammar and syntax to be perfect, but your logic has to be perfect, right? To give you an idea of logic, we have if this, then this, if this, then this, if this, then this, right? Your logic has to be perfect. If this is true, then this is true. If this is true, then this is true. If this is true, the other thing cannot be true. You have to have all of those ideas together. In this case, if if our prince chose Fair Maiden 2, he only chose Fair Maiden 2, and he could only have one output for that. Congratulations, sir. What an excellent choice. You've chosen plus Fair Maiden 2, right? You don't get anything else. You're not going to choose Fair Maiden 2 and then get a response from Fair Maiden 1. Or then choose Fair Maiden 2 and have Fair Maiden 2 for some reason be our troll, right? Because Fair Maiden 2 is not our troll. Fair Maiden 3 is our troll, which is fine and dandy, right? I'm just making all this up as I go along. But understand your logic has to be perfect, right? If you take a variable and you give it the variable value of 1, and then you give another variable and you give it the value of 2, you add those variables together, right? You're going to get one of two things. You're going to get either 1 plus 2 to give you 12, or you're going to get 1 plus 2 to get 3, right? It has to be one of those two, depending on what it is. If you put in 1 plus 2 and for some reason it pops out 6, you've done something wrong. Your logic is wrong. You have to be aware of all those, and pseudocode is what's going to help you catch those errors before they happen. Right, and this is especially true if you're working with combinations of things. Let's say you're doing a rock, paper, scissors game, right? You have to make sure that the logic is right, that rock beats this, paper beats this, scissors beats that, and then everything is good to go from there. So would you build a castle on a swampy marsh or on a grassy plain or maybe on a hilltop? Right? Where you build your castle matters, right? Your foundation, the earth itself matters, right? The pseudocode is your foundation. Right, so making sure that you have a good blueprint will keep you on track and it will keep you organized. Right, it's going to help you spot errors long before you dive into Java. That way, you're not trying to figure out if Java is screwing up or if you are screwing up. Because I promise you, experienced programmers will experience both of those times that they do silly things and times that Java just doesn't make sense. So that is pseudocode in a nutshell. We're going to dive into in the next video an example of building a pseudocode, from the ground up. But again, I want you to think about it in terms of like, this is a blueprint. This is a map. This is just destination point A to point B. Pseudocode should not be something that you stress out over. There's going to be plenty of stress to be had when we dive into actual creating a very real Java program. So thanks, guys. I will see you in our next video when we dive into a pseudocode and build one for real from the ground up. Until next time, guys. Peace.